My name is Lavina and I'm from Hong Kong, and currently I'm studying materials engineering at UCLA, so in California, and I'm an upcoming sophomore student. So I'm working at Copernic, and I've actually been on multiple projects, more than I expected. So I'm working on this project called Fab Lab project where we're working with biomaterials. I'm also working on a septic tank system project. It's called Solar Drive 4.0, where we're utilizing the Arduino and different IDE software to kind of help improve the function of a solar dryer. During work, I got to use common, easy to get materials, do chemistry. So I wouldn't have thought that I could actually create my own films in a kitchen setting as opposed to doing it in a clean lab setting. And so it's been really eye-opening to see oh, I can get these materials that are derived from seaweed and just normal calcium chloride to create materials in the kitchen. The biomat kind of mimics the function and the design of a commercial mulching mat. So the mulching mats are these black, kind of felt-like materials that we put next to trees to inhibit weed growth, so the trees have the most optimal nutrients and water to grow. However, in Indonesia or in Bali, farmers are not really familiar with these commercial mulching mats, and also it's really hard to get. So we had to actually procure it from an online source and import it, which is really expensive because of the shipping fees. So we're trying to design a mulching mat that is made of easily available materials such as coconut husk, which is the kind of fibrous substance outside of coconut that is actually going to go to waste. So we're utilizing that, and we're also utilizing a binder to kind of bind the coconut husk together. And so we are experimenting if that is a good alternative to a mulching mat. And then regarding the BioCup, similar way of how we're using coffee husk waste to create a product. This time we're using coffee bean shells to create this cup that mimics the seedling bags. The binder is made up of sodium alginate, which is derived from brown seaweed. It's also made of calcium chloride. So during this internship, I've been able to kind of learn the chemistry behind it and how exactly it actually forms a cohesive binder to bind the materials together. But then I was able to bring in my chemistry knowledge and kind of apply it to learn about these materials. So a lot of people on my team are not actually engineers or scientists. A lot of them are economists, they're humanities majors, some are biologists, but a lot of them are not familiar with these chemistry topics. So then before I came, they kind of derived this recipe for the biomaterials, but they really didn't know actually how it worked. So I kind of took charge in researching how these materials function on the chemical scale, and I was able to provide a good explanation for them. To the coffee bean sorter, that one, they kind of worked on it before I came, so I was on the latter stages of testing. But it was really cool to see how we can kind of develop from normal materials this coffee bean sorter that can really help farmers sort their beans. So normally farmers would sit on the ground for hours on end sorting individual beans by size, and so that is a really labor intensive process, and also you can imagine it's really bad for your back. So then we've developed this mesh sort of system that has different sized holes of nets that kind of stack on top of each other, and it's taken inspiration by this lunch box that's common in Southeast Asia called a rantang. So it's taking inspiration from that, and basically what it does is you pour in all the coffee beans, and when you shake it, it'll just sort by size and fall by gravity. We're utilizing waste. They're just planning on throwing away. So I did like visit Pajahan, like at the farm, and we saw like they just like piled a huge pile of like this coffee husk waste, and it was just gonna go to waste or like become fertilizer. But then if we can develop a good and equally functioning like biocup, then it'll be good to be able to use these materials for something else. Researching on the chemistry like how the chemistry works for these materials, I kind of dived in deep into the topic of like bio-based plastics. So instead of being derived from non-renewable resources such as like petroleum and fossil fuels and natural gases, they're actually derived from corn, cassava, like plants that are rich in carbon, so cellulose and starch. And so I kind of dived deep into that, and like on first thought I was like, ooh, bio-based polymers, that's like really great for the environment. But then the more I read, the more I kind of like realized it's not like that linear, and there are like a lot of caveats. So this is one topic that I hope to like kind of learn more about in the coming years. Each team member kind of contributes a different perspective, and so like some of them would contribute like, oh, how if like if we were to apply this technology, what is kind of like the response from the farmers or from whoever we're giving this technology to? While like for me, I'll be like, oh, how can we test that this is actually working? So then we were like bringing together different like ways of evaluating the effectiveness of the technology, because as an engineer, I'm thinking of like, is this going to work? Is it going to be like delivering results? But then other people might kind of think more on like the like social impact side of it. So it's been cool to kind of learn about different people's perspectives and like where they're coming from. Copernic, they do like lean experimentation, so it's like quick, low cost, very like short-term experimentations. So by being at Copernic, I've been able to kind of see many different projects and kind of like learn more about like the solutions that we can actually bring to people. Because sometimes you might like look, say like for example like the fisherman community, they might be like very opposed to upgrading their like fishing technology from like traditional nets and boats to kind of like modern technology. So then at first like thought you might be like, oh, there's nothing we can do about this because this is like deeply rooted in their culture. But then by being at Copernic, I've been able to learn about like different approaches and like kind of solutions that we can take on to tackle these situations. But I'm also on a project that is researching and compiling a report on the Aceh fishermen community. And so that's like way different than what I would expect to do. But I've been able to learn about the community and kind of deep dive into, it's not only the fishers that are affected when we kind of try to help them, we also affect the middlemen who take their fish. There's like this group called the Paglima Laut, which is kind of like the like father of like all the fishery community. So if we were to change the way fishermen fish or like do their day-to-day activities, then it's going to also affect that organization. I thought it would be a really good experience learning how like engineering can be applied to in Bali, because I like tell my friends like, oh, I'm gonna do an internship in Bali, and they're like, oh, like what exactly are you gonna be doing? And so I didn't know as well, because I didn't know what engineering looked like in Bali. All I like associated engineering was like working at like this big tech firm in like California, like the Bay Area or something. So this has been like a really eye-opening experience, how I can apply my passions to like some meaningful, like to apply to like a meaningful cause. So it's like a really amazing work environment. Technology can really help boost productivity and kind of like the flow of work in the workplace. 10 years ago, you would never think that you can have a like microcontroller, like an Arduino in your hand, and you can do so much stuff with it. But now Arduinos are like a very affordable thing that you can use to like basically do any IoT thing that you want. A lot of the times you might see like, oh, this cup is compostable, compost me. Well, the most likely scenario is that those materials actually have to be sent to specific waste management facilities. So you can't just say like you bury it in the soil and it will degrade like over like 2 weeks. You'll actually have to put it at a facility that has high temperature, high pressure environment to actually be able to biodegrade. And so that was something that I will be more aware of when as a consumer. This experience in Bali has helped me learn more about like intercultural like views kind of mixing in the workplace. So each person, like we have to kind of develop a company culture that kind of supersedes each individual culture. So it's been really insightful to see how we can develop a culture that kind of encompasses everyone that's in the workplace. This experience has been really amazing, and Start Me Up kind of hosted this like amazing first weekend, so we didn't have to plan anything and we got to actually just kind of see what kind of Bali was like. Especially, I've been to Bali but only in the south part, so it's really different than Ubud, so I was able to explore Ubud. And also Start Me Up has just provided like help throughout the whole internship. One kind of insight I got from like group discussions and our meetings is that we really have to like not zone in on creating a technology that like works perfectly. We also have to analyze how like the farmers or like the fishermen or the women in our community will actually, if they're going to utilize these materials. And also we have to like think of other environmental factors that we didn't like put into. So like for the mulching mat, we like put it there. We didn't expect it to be raining during the dry season of Bali, so then it kind of messed up a bit of our experimental procedure plans. And also apparently there was like chickens that like were playing on the mat and actually broke down one of them. So like we had 5 mats or 4, and then like one of them was just like broken because chickens were playing on it. So there's just like a lot of different environmental factors and like external factors that we have to take into account, because it's different than us trying it in the office where it's like a relatively more controlled environment.